Today, we're diving into something truly weird, one of the most mysterious and fascinating behaviors we've ever seen in artificial intelligence. It's a phenomenon called grokking, and honestly, it kind of turns what we thought we knew about machine learning completely on its head.
So here's a question for you. Can an AI absolutely ace a test, but still, not have a clue what it's doing? It sounds like a riddle, right? Think of it like a student who memorizes the answers for a practice test. Perfect score! But then you give them the real test, change just one tiny thing, and blank stare. They're totally lost. Well, that exact problem has been a huge headache for AI researchers for years, and it's the key to everything we're talking about today.
Yeah, this whole paradox has a technical name. In the world of machine learning, we call it overfitting. And it's really this constant tug-of-war between two very different things, just memorizing the answers versus actually understanding the rules so you can solve problems you've never ever seen before.
Okay, so let's really get into what that means. On one side, you have memorization, or overfitting. This is our cramming student. The model gets 100% on all the questions it's seen before. Looks great on paper, but the second the questions change, it just falls apart. Now, on the other side, we have generalization, and this is the holy grail. This is what we want. This is like the student who actually gets the concept. They can tackle new, totally unfamiliar problems because they're not just spitting back answers. They get it. They understand the rules of the game.
So this all leads us to a really fascinating study from researchers at OpenAI. They set up what seems like a simple experiment. They were training an AI on a little math puzzle. Think of it like filling in the blanks on a multiplication table or kind of like solving a Sudoku. It's all based on clear rules. But what they observed, well, it was not at all what they were expecting.
At first, everything seemed totally predictable. Business as usual. They gave the AI some of the math problems to study, and pretty quickly, boom, it memorized them. Got a perfect 100% on its training data. If you were just looking at that, you'd think, wow, this is a star student. It learned the material. But here's the million-dollar question. Had it actually learned anything? Or was it just that shallow memorization we were talking about, just cramming the answers? Well, the only way to find out was to test it on problems it had never, ever seen before, the validation set. And the result? A big, fat nope. Even with that perfect score on the stuff it had already seen, when it came to new problems, it was terrible. It was basically just random guessing. Its accuracy was what you'd get if you just threw darts at a board. So, it had memorized the answers, sure, but it hadn't learned the rules at all.
Now this is where it gets really weird. The model just stayed stuck. It was stuck in this dumb memorization phase for an incredibly long time. We're talking more than 100,000 training steps went by, way after it had already gotten a perfect score on its training set, and still nothing, no sign of any real understanding. It was just spinning its wheels, going nowhere.
And then, just like that, out of the blue, something clicked. Suddenly, everything changed. Its performance on the new problems, the ones it had never seen, it didn't just slowly get better. No, it jumped. It went from random guessing all the way to a perfect score almost instantly. It was this massive aha moment before a machine. So the researchers saw this and thought, what do we even call this? This weird delayed lightning bolt of understanding. They actually borrowed a word from a classic sci-fi novel, Stranger in a Strange Land. They called it grokking. To grok something means to understand it so deeply and intuitively that it becomes part of you. And that's what this is, a sudden, profound jump to perfect understanding that happens long after it's finished memorizing.
Okay, so naturally the next question is, how? How did they make this happen? Was this just some random fluke? Well, it turns out no. There's actually a recipe, a set of specific conditions you can use to make this AI aha moment happen on purpose.
All right, so here's the secret sauce. Step 1, you need a simple puzzle that's based on rules, something like modular division. Step 2, and this is the really important part, you hide most of the answers. You only train the AI on a small piece of the puzzle, say half the equations. This makes it super easy to just memorize the answers you've shown it, but way harder to figure out the underlying pattern. And then step 3, you just let it cook. You keep training it, and training it, and training it, way past the point where it's already memorized everything. You're basically forcing it to get bored with memorizing and start looking for a deeper, more elegant solution. And this revealed something totally counterintuitive. This trade-off between data and, well, thinking time. If you give the model less data, it actually pushes it to find the real pattern, to generalize. But the catch is, it takes a lot more time, a lot more computation. It's like, by starving it of easy answers, you force it to stop being lazy and actually start thinking, to find the real rule. So, let's be real. Nobody wants to wait around for hundreds of thousands of steps for their AI to have a breakthrough. It's just not practical.
So the next obvious question the researchers asked was, okay, is there a shortcut? Is there some way we can speed this up and trigger that aha moment faster?
So they tried a whole bunch of different tricks, and one of them worked like a charm. It's a technique called weight decay. The easiest way to think about it is like a penalty for being too complicated. It basically encourages the AI to find the simplest, cleanest, most elegant solution possible, instead of some big messy tangle of memorized facts. And it's pretty clear this worked. Using weight decay made the grokking happen way faster. It's like giving the AI a little nudge, saying, hey, stop cramming. Look for the simple, beautiful pattern instead.
Okay, this is all really cool stuff. But now we get to the part that, for me, is just mind-blowing. The researchers didn't stop at just seeing that the AI learned. They figured out a way to peek inside its brain and see what it actually learned. They could literally visualize how it was organizing the information.
And what they saw internally was just wow. So before it had that grokking moment, its internal representation of the numbers was just a chaotic mess, a total jumble, no logic to it at all. But after it grokked, something incredible. The AI all by itself had organized the numbers into a perfect circle. It had discovered the number wheel, which is the fundamental geometric structure of modular math. It figured out the very shape of the problem it was trying to solve without anyone telling it to.
And I just have to say that again, because it's so important. Nobody told the AI about circles or numbers or what modular math even is. It was just fed a bunch of abstract symbols and told which equations were true. From that alone, it discovered this beautiful, hidden geometric structure, all on its own, just by chewing on the patterns for a long, long time. So you might be thinking, okay, that's a neat trick on a simple math puzzle, but why does this actually matter? Well, it matters a lot, because this gives us a rare glimpse, a tiny window into the black box of how these incredibly complex AI systems might actually be learning. And it really makes us question some of our basic assumptions.
So what are the big takeaways here? What have we learned? Well, first, that real understanding can pop up way late in the game, long after it looks like a model is done learning. Second, we learned about that crazy trade-off where you can swap data for more computation. More thinking time can force an insight. Third, these simple little puzzles are like a perfect petri dish for studying how AI really learns to generalize. And maybe most importantly, it shows that AI might be learning in ways we just don't expect, in these surprising, emergent ways that we don't fully understand yet.
And this leaves us with a pretty big and honestly kind of spooky question. Remember, this was all found in a simple, controlled little math problem where we could actually check the AI's work and see its insight. But now think about the giant models out there, the ones trained on basically the entire internet. If they can also have these sudden, hidden aha moments, what else are they learning? What other hidden patterns and deep structures are they quietly figuring out when we're not looking? What else might they be grokking right now, right under our noses?